I'm Adelbert Chang. I'm a lead data engineer at Target, and I work on deployment infrastructure for the data science and optimization team. One thing that I do a lot is try to do automated deployment infrastructure, so automatically deploy, heal, scale out systems, and this tends to be very tricky because of things like people are going to be using different languages. Different languages will re-implement the same thing over and over. How do we abstract that away? And I think what we're seeing now in projects like Kubernetes, Nomad, Envoy is moving that functionality out of the language and sort of having certain patterns so that we can reuse the same infrastructure to do things that are critical to our system. So before we had schedulers that was very specific for MapReduce jobs. Now we have just like generic schedulers that can schedule services just as well as they can schedule batch jobs, for instance. And I think that's a trend that we're seeing and something I'm really excited about. I think automation will be a big one. As you get, like, so for instance, when you want to scale up a service because you see increased load or something, you want to be able to very easily hit a button and have it scale out, maybe preferably automatically. And that tends to, you need to have a notion of like, all right, where do I get the machines? Where do I get the power from in order to scale up these services? How do I provision them so that they all of their logs get shipped to the same location that I expect? How do I get the metrics from them? And if this is a manual process, then this becomes very tedious, as it's been in the past for me. So I think as we're seeing this surge of like automated infrastructure, then that becomes more and more of a solved problem, but we're still early stages. But I think automation is definitely a big one in there. So on my team, we write a lot of Haskell code, so we do a lot of functional programming in the team. And it's helped us a lot because it's given us a lot of confidence in what our code does. And the nature of our work is very math heavy. So we work in supply chain optimization, which has a lot of, is very math heavy. And when we go to implement this algorithm in Haskell, because of the way Haskell looks and because of sort of the theoretical foundations that Haskell is rooted in, our implementation ends up looking pretty similar to the equation that you would see on paper. So functional programming gives us assurances both from a mathematical perspective, but also from like a global program-wide perspective, where we're able to look at a chunk of code and understand it reasonably well to be confident in deploying it to production. My favorite part is I've been attending this conference since the first iteration back when it was at Intel, and it's been really cool to see it grow. What I particularly like this year is how Alexi has really recognized the conference as not just Scala specific, but just like a variety of different tracks, from data to functional programming to systems. And so I think the most exciting part about the conference is you have all of these very interesting topics all together in one conference, and to my knowledge, there's not many other conferences out there that provide the same mixture of disciplines.